Dear first year students, now we are continuing limits. See here, there is a theorem. Of course, we need not to prove that theorem. Only thing is we will take the results. See, proving theorems in calculus, okay, in the point of examination view, there is no importance, okay. So, just take that theorem and use the results in exercise problems, okay. The theorem is, if theta is or x is, if x is measured in, radians, sin x, limit x tends to 0, is equal to 0. Cos x, limit x tends to 0, equal to 1. Third one, tan x, limit x tends to 0, is 0. Are you following? Number 4, sin x by x, limit x tends to 0, is 1. Please, all these results we use in running problems, so every student least responsibility is to remember these. Anyhow, you are not proving, at least remember those results. Fifth one, sin ax by x, limit x tends to 0, is equal to a. Please do understand this. Sixth, tan x by x, limit x tends to 0, equal to 1. Seventh one, tan ax by x, limit x tends to 0, equal to a. Are you following? Please note all these results. Next, sin x minus a by x minus a, limit x tends to a, is equal to 1. Are you following? This is 8th. Ninth one, tan x minus a by x minus a, limit x tends to a, is equal to 1. Are you following? So, these are the 9 results which we frequently use, okay, to solve the problems. And if you want, you can go for one more property, that sin mx by sin nx. Are you following? Limit x tends to 0, equal to m by n. Are you following? Similarly, you can go for tan mx by tan nx, limit x tends to 0, is equal to also m by n only, okay. So now these are the 10 most important useful results which we use, okay. Now let us go for problems. We solve these problems using these results. So the first question is, evaluate the following limits. In the heading is evaluate the following limits. That is the heading. Under this heading, the first question is 1 minus cos x by x square as limit x tends to 0. This is the problem. So we have to evaluate 1 minus cos x by x square as limit x tends to 0. So from trigonometry you have a formula. 1 minus cos x is equal to sin square x by 2. Do you remember this? In trigonometry, from trigonometry we have the formula 1 minus cos x is equal to sin squared x by 2. So if you take this limit, okay, so solution, so this is equal to, now 1 minus cos x can be replaced with 2 sin squared x by 2 by x square as limit x tends to 0. Now this 2 being constant, okay, that can be taken outside the limit. So sin squared x by 2 by x square as limit x tends to 0. Are you following? So this is equal to 2 into sin squared x by 2. So now here you take x square by 4 into 4. So I divided by 4 and multiplied by 4 as limit x tends to 0. It's equal to 2 into, now this 1 by 4 is constant, this 1 by 4 is constant, can be dragged out. Now this is sin x by 2, x square by 4 can be written as x by 2 whole square, but see, both are having squares, so on the whole you can put one square like a whole square. So this is a whole square, limit x tends to 0. As x tends to 0, x by 2 tends to 0. So now this is in the form of sin theta by theta, limit theta tends to 0. So it is 1. So 2 into 1 by 4 is 1 by 2, 1 by 2 into 1. 1 by 2 into 1 is 1 by 2. So this is the answer for this question. So now I am going to the next question. The next question is 1 minus cos 2mx by 1 minus cos 2nx. So our next question is to evaluate 1 minus cos 2mx by 1 minus cos 2nx, limit x tends to 0. See, from trigonometry we have a formula 1 minus cos 2 theta is equal to sin squared theta. So here mx is playing the role of theta. So if you use that identity, then here this would result as 2 sin squared mx, and this would result as 2 sin squared nx as limit x tends to 0. Now what happens, the 2 and 2 get cancelled. So sine squared mx by sine squared nx, or sin mx by sin nx as limit extends to 0, the whole squared. You can take in this way. So as already I have given among the 10 standard forms, this is m by n. It is one of the standard forms, m by n whole square. That in the previous context I have discussed the theorem m, that I have given 10 results, right? Among those 10 results, this is one of the results. So this is m by n whole square, which is m square by n square. Understood? So we have to evaluate the next limit, limit tan x minus sin x by x cube as x tends to 0. So now I am starting the solution. So the solution is equal, this tan x can be written as sin x by cos x, right? So and if you take that cos x LCM, sin x minus sin x cos x, so by x cube into cos x it will come. Did you understand? I took cos x LCM. I wrote tan x as sin x by cos x. So I wrote tan x as sin x by cos x, and I took cos x LCM. So we get this as limit x tends to 0. So now here you take sin x common. So in the two terms there is sin x common, you take sin x common. So after taking sin x common, you will have 1 minus cos x. Are you following everything? So by x cube into cos x as the limit x tends to 0. This is equal to sin x into, what is 1 minus cos x from trigonometry? It is 2 sin squared x by 2. So it is 2 sin squared x by 2. From trigonometry, 1 minus cos x is equal to 2 sin squared x by 2 by x cube into cos x as the limit x tends to 0. Are you following? So now this is equal to, now you take 2 outside as it is constant. Please take 2 outside. Now take sin x, and here there is x cube. So use x, 1x, limit x tends to 0. So still we have to use x square, because x cube is x into x square. I took x, okay, upon sin x, okay. Now here you take sin squared x by 2. Are you following? And that one in the x cube we have used x, now use x square here. So that x into x square would be x cube. So there is no wrong in that. Okay, so as limit x tends to 0, now you write 1 by cos x, because it is the last term which is left over, 1 by cos x, limit x tends to 0. Are you following? So now from that standard limit it is 1, so it is equal to 2 into 1. Are you following? Now here limit x tends to 0, sin squared x by 2, so divided by x square by 4 into 4, right? So into cos x limit x tends to 0 is 1. One of the 10 results which I have given. So now here that 1 by 4 comes out. So this is equal to 2 into 1 by 4, and it is sin x by 2 by x by 2 as limit x tends to 0 whole square. As x tends to 0, x by 2 also tends to 0 into 1. So 2 by 4 is 1 by 2 into 1 square, which is 1 by 2. So the final result of this is 1 by 2. Understood? See, dear students, we are evaluating some more interesting limits. The first one I am evaluating is cos x by pi minus 2x as limit x tends to pi by 2. So, here this expression is involving trigonometric function in x, where x is tending to a, where a is not 0. So x is approaching to a non-zero quantity. So when x is approaching to a non-zero quantity, and if that function is involving trigonometric functions in x, where x is approaching to a non-zero quantity, how to evaluate the limits? This is our central idea. Understood? Once again I will repeat. See, we are evaluating, okay, the limits of some functions involving trigonometric functions in x, where x is approaching to a non-zero quantity. So now this is a problem. So now in this kind of problems, what you have to do is you have to change the variable. Suppose, for example, so solution, see, put pi minus 2x, say some theta. So if you put pi minus 2x is equal to theta, this implies pi minus theta is equal to 2x. Implies pi by 2 minus theta by 2 is equal to x. This implies x is equal pi by 2 minus theta by 2. So when pi minus 2x is equal to theta, x is equal to pi by 2 minus theta by 2. Also, when x is approaching to pi by 2, obviously theta approaches to 0. See, if you replace x here with pi by 2, so 2 gets cancelled, pi minus pi 0, theta is 0. So when x is approaching to pi by 2, obviously theta approaches to 0. Now this problem, cos x by pi minus 2x with limit x tends to pi by 2 changes its variable from x to theta as cos. Now replace this x with pi by 2 minus theta by 2. Are you following? Divided by pi minus 2x is theta. Are you following? Limit theta goes to 0. So theta tends to 0. So now this is equal to cos pi by 2 minus theta is sin theta. So this results as sin theta by 2 by theta by 2 into 2 multiplied and divided by 2. Limit theta tends to 0. This 1 by 2 constant you can write outside. So sin theta by 2 by theta by 2, limit theta tends to 0. As theta tends to 0, theta by 2 tends to 0. So this is equal to 1 by 2 into 1, which is 1 by 2. So this limit value is equal 1 by 2. So now I am doing another problem. So I am doing another problem, that is sin 3x minus 3 sin x upon pi minus x the whole cube as limit x tends to pi. So I am doing this problem. So now what you have to do as this solution, so you have to put pi minus x is equal theta. This implies pi minus theta is equal to x. Are you following? Also, as x tends to pi, obviously here pi minus pi 0, theta tends to 0. So as x tends to pi, obviously pi tends to 0. Sorry, pi minus pi is equal to 0. So theta tends to 0. So as x tends to pi, obviously theta tends to 0. Are you following, Babu? See here, I have taken pi minus x is equal to theta. So then this will become by transposition pi minus theta is equal to x. Now here according to the question, x is approaching to pi. So when x is approaching to pi, here you put pi minus pi 0. So theta is 0. So obviously when x approaches to pi, theta approaches to 0. So now take the given problem, sine 3x minus 3 sine x by pi minus x whole cube, limit x tends to pi. Now take this given limit and now change the variable. Now sine 3 into x. What is x, Baba? Here just now we have seen x is equal to pi minus theta. So sine 3 into pi minus theta. Are you following? Minus 3 into sine x means pi minus theta. Did you understand? So divided by pi minus x is theta. So pi minus x is theta. Limit theta tends to 0. So this is equal to sine 3 pi minus 3 theta. I am multiplying. Minus 3 into sine pi minus theta. Pi minus theta lies in second quadrant. So sine pi minus theta is sine theta only. So it is sine theta by theta. Limit theta tends to 0. Now you see, here just take rough work. So this is 0, this is pi by 2, this is pi, this is 3 pi by 2, this is 2 pi, right? Are you following? So this is 2 pi plus pi by 2, which is pi by 2 here. Now pi by 2 plus pi by 2, which is 6 pi by 2, right? It is 3 pi. So 3 pi will be on OX dash. Now 3 pi minus 3 theta obviously goes in second quadrant. So it results as sine 3 theta. So this is sine 3 theta. Are you following? Minus 3 sine theta by theta. So limit theta tends to 0. Now from trigonometry we have one identity. Sine 3 theta is 3 sine theta minus 4 sine cubed theta. So minus 4 sine cubed theta. So minus 3 sine theta. Right? I use the identity for sine theta. Sine 3 theta. I use the identity for sine 3 theta in trigonometry. So by theta is equal to limit theta tends to 0. Then what happens? This and this gets cancelled. Right? And in the question, it is pi minus x whole cube. So here theta cube will come. So in the question, in the denominator, there is pi minus x whole cube. Have you seen that? So as in the denominator, there is pi minus x whole cube. Pi minus x is theta. So it is theta cube. So now minus 4 constant which comes out. So sine theta by theta, limit theta tends to 0. The whole cube. So this is equal to minus 4 into, so this is 1 cube, which is equal to minus 4. So that limit is minus 4. Here you see, very simple. In the given function, denominator is pi minus x whole cube. So we have considered pi minus x is theta. So in denominator, the moment you have changed the variable in the denominator, theta cube will come. Okay. So this ends the problem. So next question is, cot x by pi by 2 minus x as limit x tends to pi by 2. Chalo, same procedure, put pi by 2 minus x is equal to theta. So this implies pi by 2 minus theta is equal to x. Also, as x tends to pi by 2, so here pi by 2 minus pi by 2 is 0. So obviously theta tends to 0. So now take the problem, cot x by pi by 2 minus x as limit x tends to pi by 2. So this is equal to cot x means pi by 2 minus x divided by pi by 2 minus x is theta. Now limit theta tends to 0. Cot pi by 2. Are you following? X is pi by 2 minus theta. So cot pi by 2 minus theta by pi by 2 minus x is theta. Limit theta tends to 0. Cot pi by 2 minus theta is what? Tan theta. So tan theta by theta, limit theta tends to 0. So which is equal to 1. So the answer for this question is 1. So our next question is, pi by 2 minus x into tan x, limit x tends to pi by 2. As the solution, so put pi by 2 minus x equal to theta. This implies pi by 2 minus theta equal to x. Also, as x tends to pi by 2, theta tends to 0. So now take the question, pi by 2 minus x into tan x as limit x tends to pi by 2. I took the question. So now this is equal to pi by 2 minus x is theta into tan x means pi by 2 minus theta, limit theta tends to 0, which is equal theta into tan pi by 2 minus theta is cot theta, limit theta tends to 0. It's equal theta into cot theta is theta by tan theta, limit theta tends to 0. So which is equal to 1. So this answer is 1. So if you go another problem, go for another problem. Two power n into sine a by 2 power n, limit n tends to infinity. So this how I am evaluating, you see here I am dividing numerator and denominator with 2 power n. So 2 power n to sine a by 2 power n by 2 power n divided by 1 by 2 power n. So both numerator and denominator are divided by 2 power n. So limit n tends to infinity. Now this 2 power n get cancelled. So sine a by 2 power n. Are you following? By 1 by 2 power n. Limit n tends to infinity. So here you multiply and divide by a now. Are you following? So sine a by 2 power n divided by a by 2 power n. Are you following? Into 1 by a. Limit n tends to infinity. So this 1 by a, it is a that comes out. So now sine a by 2 power n by a by 2 power n, limit a by, okay, limit n tends to infinity. This 1 by a is a, I have taken outside, then it's what left over. Now as n tends to infinity, a by 2 power n tends to 0. So now this takes the form limit theta tends to 0, sine theta by theta. Okay, just we are changing the variable. If you want more clearly, you can take like this. Put a by 2 power n equal to theta. As n tends to infinity, we have theta tends to 0. Then a into sine theta by theta, limit theta tends to 0, which is equal to a into 1, which is equal to a. This is the problem.